Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 6.4. It says to assume that a population of 1, 3, and 8. We have a population of 1, 3, and 8. Assume that samples of size n is equal to 2 are randomly selected with replacement from the population, and listed below are the 9 different samples, and we want to complete some parts here. They want us to find the value of the population standard deviation, so that's 1, 3, and 8. Let's copy this onto our clipboard and paste it onto Google Sheets so we can use this as some sort of reference. And the first thing they want is the standard deviation of the population, and the population is a set 1, 3, and 8. So there is a command called stdev, and then if we put 1, 3, and 8 as just the regular raw numbers in there, it looks like the standard deviation will be 3.6 or 3.6055. Now unfortunately, this is the sample standard deviation. This is not what we want. We want a different standard deviation command that deals with the population, and that is going to be equals stdev, and then there's several with p's in it, so the ones with p's will be the population standard deviation. And then we'll type in the population. In this case, it's a really small population, just 1, 3, and 8. And our population standard deviation is 2.9439. .9439 rounded off to 3 decimal places will be a 4. That's 2.94. Now they want us to find a standard deviation of each of the 9 samples and summarize it using the table. Now these are going to be sample standard deviations, so we can use the regular sample standard deviation. Let's make a little bit of room here and say that this is a sample standard deviation. It's usually denoted by just the letter S, and I will say equals stdev. That's just a standard deviation for the sample, and then for this I will take in 2 values at a time because these are really small samples. So the standard deviation for 1 and 1, because they're the exact same thing, they don't deviate from each other, that's the deviation of that is 0. Between 1 and 3 we'll get something non-zero, so let's just copy and paste all the formulas down so we get all the standard deviations. So it looks like I have 3 of them are going to be zeros, and then there's a 1.4, a 4.9, and a 3.5, and then everything else kind of repeats. And so they want us to identify the different types of standard deviations that we're getting. Let's go from, it looks like it's going from smallest to largest. The smallest is 0. The next is at 1.4. The next is at 3.5. And then we have 4.9. Now they want us to find the probability of getting each of these things. Well, all we have to do is count how many times we see each of them. So for zeros, how many times do we see that? I'm going to use the little fill highlighter button we see that 3 times. So with a 0, we see that 3 out of 9 times. The next value is 1.4, and it looks like we see that twice. That's 2 out of 9 times. The next value in increasing order is 3.5, and we see that twice also. That's 2 out of 9 times. And then finally, that last one, we see that twice as well. That 4.95 value, or 96, is going to be twice. Now, I think they want us to round this off or simplify the fraction, so I think the first one should be 1/3. So the probability of getting 0 is 1/3, and then the rest are going to be 2.9. Let's check that. Okay, that looks good. And then finally, they want us to find the mean of the sampling distribution of the sample standard deviations. So find the mean of all the standard deviations that we calculated. Let's go back over here. These are all the standard deviations that we calculated. Let's find the mean of that. And remember that the mean for these spreadsheets has a formula called average. I'll click and drag the data that I want the average of, and I'll hit enter. Get 2.1998. That is 2.1998. Round off to 3 decimal places. 8 is bigger than 5, so that's going to go up by 1, which is 0. It's going to go up by 1, so it's 2. We can put a 0, 0 there. And then that's it. Finally, they want to ask us, do the sample standard deviations target the population standard deviation? In general, do the sample standard deviations make a good estimator for the population standard deviation? So if we compare the values that we just got here and the population standard deviation here, we have 2.9 versus 2.19. It doesn't look like it hit that very well. Sample standard deviation do target, therefore the standard deviation, sample standard deviation, are unbiased estimators. Well, I think we have to choose the ones that do not target because they're not equal to each other. And then we ask the sample standard deviation by our biased estimators or unbiased estimators. I think they would be unbiased estimators if you're targeting them correctly, so I think I will stick with B. They are biased estimators. Let's check that. All right. I hope that helps.